Hi everyone, this is Dr. Manjunath Chennapgood from Anveshana Academy, Bangalore, India. I welcome you to my YouTube channel Anveshana Academy. Dear students, in the previous class we were discussing about thermodynamic process. There are different types of thermodynamic processes are there. Reversible process, irreversible process, flow process, non-flow process, cyclic process and non-cyclic process. In the previous class we were discussing about reversible process and irreversible process. With the examples in detail, we have discussed what is reversible and irreversible process. Dear students, let's come, we will move towards next topic, that is thermodynamic process. In that thermodynamic process, today we are going to discuss what is flow process and what is non-flow process. Dear students, you can see now. First, I will try to read the definition of the flow process and non-flow process with some examples. I will try to explain you what is flow process and non-flow process, dear students. What is flow process? That we can see. In a flow process, the system is open and the mass crosses the system boundary. A process in which mass is going to crosses the system boundary. Dear students, we have discussed in detail what is system, what are the different types of system, how it is open and closed, that we have discussed in detail. Okay, in the previous classes. Okay, fine. Then a process in which what will happens, it is an open system. You can take an open system. In that what will happens, the mass is going to cross the system boundary. This is what system, the system is surrounded by a boundary, that we can call it a system boundary, SB, system boundary. If the mass is going to cross the system boundary, then that process we can call it as a flow process. Flow process is a process in which mass is going to cross the system boundary in an open system. That is known to be flow process, dear students. Examples, you can take turbines, you can take compressor, pumps, nozzles and diffusers. These all are examples for what? Flow process. Okay, fine. What is non-flow process? Non-flow process. In a non-flow process, the system is closed and mass does not crosses the system boundary. That means what, dear students, you can take the non-flow process. It is a closed system. Okay, in a closed system what happens, the mass is not at all crossing the system boundary. The mass is not at all crosses the system boundary. If the process happens in such way, that process we can call it as a non-flow process. What is non-flow process? Non-flow process is a process in which there is no mass crosses the system boundary in a closed system. That is known to be non-flow process. That already we know, dear students, what is closed system and open system. Open system we know, right? The mass and heat energy, both they are going to crosses the system boundary in open system. But when it comes to closed system, but there is no mass transfer, but heat may, there is no mass transfer, but heat may get transferred. That is what? Closed system that we have know. But when it comes to flow process, we are going to take open system. In open system, what happens? Now, mass is going to cross the system boundary. If the mass across the system boundary, that process we can call it a flow process. If the mass is not at all crossing the system boundary, then that we can call it as a non-flow process. What are the examples for non-flow process that you can see here, dear students? Piston cylinder devices you can say, pressure vessels you can take, and boilers you can take. Okay, this is what definition of what flow process and non-flow process. Dear students, let's come in detail. We are going to discuss what is flow process and what are the live example for flow process and non-flow process that we are going to discuss today. Okay, now you can take, dear students. Now you can take an example. You can take an example, radiator. Okay, when radiator, right, then water will enters into the top here. Now assume that the hot water is coming at this bottom in the radiator. Now that means what? Radiator you can call it as a system. Okay, radiator you can call it as a system. If the hot water is coming out, that means what? The hot water is coming out means what? Hot water certain quantity. That means what? Mass also is going to crosses the system boundary. Okay, if the mass crosses the system boundary in a process, that process we can call it as a flow process. Flow process is a process in which the mass is going to crosses the system boundary. Example, where it is going to cross the system boundary? Open system. In open system, what actually happening now? The mass is going to cross the system boundary. That process we can call it as a flow process. That process we can call it as a flow process, dear students. Okay, one thing. Next, one more example. So you can take a kettle you can call it as a system. You can assume that it is a system. It is having a boundary, right? When you are going to pour the hot tea, right, the hot tea is coming out. That means what? The mass is going to transfer. If the mass during a process, If the mass is going to crosses the system boundary, you can call it a system boundary. If the mass is going to crosses the system boundary, then that process we can call it as a flow process. That means what? Flow process is a process in which the mass is going to crosses the system boundary in a open system. That is known to be flow process, dear students. Now, if suppose what is closed process? What is non-flow process? Assume that, dear students, it is completely insulated. Completely assume that radiator is completely insulated, and assume that it is completely closed. There is no hot water is coming out. If there is no if it's so, if you closed it perfectly, and you insulated it perfectly, that means what? If there is no mass transfer, okay, you close this, right? You close this completely. If the mass is not at all coming out, that means what? The mass of the water is not coming out. If the mass or flow rate is not coming out of the radiator, then during a process, that process we can call it as a non-flow process. Non-flow process is a process in which there is no any mass across the system boundary. That is known to be non-flow process, dear students. That radiator you can call it as a flow process or non-flow process, depends upon the condition. If you are allowing water to come out from the system, flow process. If you are not allowing you are not allowing to flow water from system to the surrounding, then it is something but what? Non-flow process. How it is, that you can see. These are the two examples we have taken. Now we can take technical examples, and I will try to explain you now. Now assume that, these students, during a compression there is a piston and cylinder arrangement. Gas is there already. I will compress the gas. Okay, the gas will be gets compressed, and due to sometimes again it may expand. The piston and cylinder arrangement you can take, sometime it will be compressed, sometime it will be expand. Okay, assume that. Okay, during compression also the gas is going to get compressed, but the gas during a process, compression process, the gas is not at all coming out. But because why so? Because there is no any provision to move out of the gas from the system. But during a compression and expansion process, the mass remains constant. There is no movement of mass in a process. That process we can call it as a non-flow process. Non-flow process is a process in which the mass remains constant, but the boundary may vary. During a compression, this boundary may get compressed. During expansion, that boundary may expand, but the boundary may vary, but the mass is not at all moving. That mass is not at all changing. That means what? Mass remains constant. You can take this example. Again, if you provide a small opening for the same arrangement, then what will happen? The warm air, whatever the compressed air is, right, it will come out. If the mass of the air is come out, that means what? We can call it as a flow process. How it is, that we can see here, dear students. Now the same arrangement I will take it here. Now I will take gas inside here, then the gas will come out here. Now okay, when it is compressed, right, if the gas is coming out, right, that means what? The certain amount of mass is going to cross the system boundary. If mass crosses the system boundary in a process, that we can call it as a flow process, dear students. Flow process is a process in which what happens? The mass is going to cross the system boundary. That we can see open system. We can take in open system, that mass is going to cross the system boundary. This is about flow process and non-flow process, dear students. Now example, what is flow process? Key points. Flow process in which what happens now? Mass is going to transfer. There is a movement of mass across the system boundary. Where it is going to happen? It is going to happen in the open system. What are the examples you can take? Steam flow, water flow, and air flow. Okay, these are examples for what? Flow process, that you can see here now, dear students. Now okay, now examples for flow processes, what you can see? Steam flow in a turbine, okay, and nozzle. That means what, dear students? You can take it here now. Okay, assume that steam is entering and it is leaving. That means what? Steam enters and it is leaving. That means what? Mass, you can assume that, okay, you can assume that this nozzle is a system in which what happens? Steam enters and steam exits. That means when it is exiting, right, that means steam is going to crosses the system boundary. That is known to be what? It's an example for what? Flow process. Like you can take water flow in a turbine. When water is coming, right, when the water is coming from the penstock and it is going to hit the turbine. If the water is going to crosses the system boundary, you can take a penstock as a system. That means what? Certain quantity of water, that or mass of water is going to cross the system boundary. That is known to be what? Example for a flow process. Then you can take air flow through a compressor. Okay, you can take in AC. In AC, what you are doing? You are compressing air, right? That compressed air is coming out of the system, means what? Again, flow process. These are what example for flow process, dear students. Now you can get n number of examples for flow process that you can see here. Now in detail I have discussed again in what? Control volume, dear students. You can see here now. These all are what? Flow process. Why it's so flow process? I will take it here now. When you are going to spray, right, with the help of one bottle, spray bottle, when you are going to spray water or something else, right, it is coming, this you can nozzle here, there will be a nozzle, you can call it as a nozzle. Then certain quantity of mass or water is coming out of the system. That means what? It is going to cross the system boundary. If the certain quantity of mass or water is going to cross the system boundary during a process, that process we can call it as a flow process. Like that you can take n number of examples, dear students. Okay, pesticides spraying you can take. When it comes to engine, exhaust emissions is coming out of the system. Okay, that means what? The exhaust emission is going to cross the system boundary. That also you can take flow process. Like that you can take n number of examples, dear students. Now here you can see pesticides, you can take water spray, you can take from the bottle, water flow in the things, water flow in the turbine, dam, you can take a pesticide, you can take a fertilizer spraying. These all are examples for flow process we can take, dear students. Now I will move towards next topic, non-flow process. What is non-flow process? It's a thermodynamic process in which what happens now, as I told, the mass remains constant. It's a thermodynamic process in which mass remains constant. Where it is going to happen? In a closed system. Mass is fixed. During a process in which mass is fixed. Boundary may change, property may change, but mass remains constant. That type of process we can call it as a non-flow process. Where it is going to happen? It is going to happen in a closed system. Okay. Examples, you can take practical instances of non-flow processes. What are the examples? That I will show you here, dear students, now. Okay. Instant examples, you can take it now. When you are heating, you can take some substance into the container. When you are going to heat it, right, assume that it is completely closed. There is no provision to transfer any kind of substance from system to the surrounding. If it is completely closed, when you are heating, right, that means what? There is no transfer of mass during a process. That means what? Heating, you can call it as a heating process. In the heating process, there is no transfer of mass from system to the surrounding. That process we can call it as a non-flow process, dear students. One thing. And gas expansion and compression. As I told earlier, when you are going to compress the gas and when we are going to expand the gas, right, the boundary may shifted, boundary may change, but there is no mass transfer at all. Mass remains constant. If it's so, that we can call it as a non-flow process. Okay, heating water in a closed container. You can take water in a container. That also you can do. You close that container with a perfectly on a lid actually. Okay. Then what happens now? But when we are going to heat it, right, there is no mass transfer to the surrounding or from system to the surrounding. Mass remains constant during a process. That means what? Heating process. That we can call it as a non-flow process. How it is now? As I told, dear students, I was telling you. But boundary may change, property may change, but mass is not at all getting changed. If it's so, that process we can call it as a non-flow process. Non-flow process is a process in which what happens? The mass remains constant, but boundary may vary, boundary may change, or there may be change in state. The property may change, but mass remains constant. That process we can call it as a non-flow process. How it is? That you can see here, dear students. Now, I will take in a container, piston and cylinder arrangement. I will take 2 kg of gas initially. Okay. Then what I will do? It is going to have some volume 1 meter cube, mass 1 kg, mass 2 kg. I have taken one gas. I will heat it now for a few minutes or 1 minute or 2 minutes. When we heated it, right, this piston is moved from this point to, when initially it was at this point, right, when we heated it, the piston is moved from this point to this point. We can take it now. That means what? Volume is increased from 1 meter cube to 1.5 meter cube. That means what? Initially V1 is equal to 1 meter cube. When we are going to heat it, right, the volume changed to 1 to 1.5 meter cube. That means what? Property is changed. Because of the volume, increase in the volume, expansion on the piston moved here now. That means what? Boundary, system boundary is shifted. from this point to this point. The boundary is getting move, but mass is not at all change. You can see here now, mass here is 2 kg, here also is 2 kg. M1 is also 2 kg, M2 is also 2 kg. Here, if the mass M1 is equal to 1 kg and 1 kg and M2 is also 1 kg, mass remains constant, but the other property may change, volume may change, but pressure may change, but mass remains constant. That process we can call it as a non-flow process. Non-flow process is a process in which what happens, mass remains constant, there is no mass transfer across the system boundary. During a process, that process we can call it as a non-flow process, dear students. I hope you understood my videos. If you really understood my videos, please do like, subscribe and share to your friends. Thank you.